Welcome everyone. Today we will learn how to implement the UnitOfWork pattern with Entity Framework Core in a .NET Web API. So as a prerequisite, we need to have a SQL Server instance running on Windows. You can check out my video about the repository pattern, which I explain how to run a local instance with Docker. And for this demo, we'll use a simple clean architecture schema. So you can pull the sample code from my video about clean architecture. I'll provide the links in the description below. So the first step is to create the DbContext and connect with the local database. So add a NuGet package in the persistence layer, entity framework code.sql server, install the latest version. Let's add a new class called context. Add the default configuration by inheriting from the DbContext, and then by a constructor pass the DbContext options to the base constructor and declare two properties which represent two tables in database. So create a dbSet of type user and another dbSet for the order table. So the user will contain two simple properties, ID and name. Let's define the order class in the domain layer. Add a new class called order and then specify some properties, a primary key, product name, finally foreign key for the user ID, and also a navigation property to access the user entity. Now go and register the connection with the database in the extension method, which is called in the program.cs file. So add the DbContext, pass the options, which will be use SQL Server by passing the connection string. So let's put the connection string in the app settings.json. So we will access the iConfiguration interface. Go to the API, to the app settings.json, add the connection string section, and then define property, which will contain our connection string. So let me copy the value, copy the key, and then here call configuration that get connection string by passing the name. The next step is to create the database and the schema by applying code fast migrations. So go to the program.cs file before creating the schema, pass the configuration to the extension method. And now how to create the schema and the database. In the starter project in the API, let's add a NuGet package called entity framework code.design to perform migrations. In order to run migrations through the command prompt, we need to install a tool called the Entity Framework 8 command line interface. So how to install the tool globally? Just copy this command. This is a Microsoft article. So copy the command and select the same version that the Microsoft Entity Framework Code.design package, which is 8.0.3. Install the same version. Now go to the started project, which is the API, and create our fast migration. So let's copy this command from the Microsoft documentation, paste it here, and define the project which contains the context, which is the persistence project, and execute the command. There is an error, so let's build the solution. Everything looks good. Let's run again the same command. That's it. Let me clear the console. As you can see in the persistence layer, we have the migrations folder. Now let's create the database and the schema by running the second command. Let's execute it. The next step is to create the generic repository. So let me close all the tabs, and in the persistence layer, go to the database service class, rename it as generic repo, which will be of type T, which implements the iGeneric repo. Let's rename it, which is located in the application layer. This is a generic interface and add a constraint for the T generic type. Define two simple methods for demo purposes. One method to create an entity and the second method to get an entity based on the ID. Now go to the implementation class, remove this line and implement the interface. Now inject the context by a constructor injection, define a private field and add simple logic to connect with the database and get or to create an entity to call context.add and return the entity being tracked. Finally, for the get method, just call context.find by passing the generated parameter and the ID via an argument. Now go and register this generic repo in the persistence installers class. So this will be the service type of type iGeneric repo and the implementation type. So the next step is to implement the UnitOfWork class with the contract associated. So in the same persistence layer, add a class called UnitOfWork, which will implement the contract method defined in the application layer. So let me copy the name, add a new interface called a UnitOfWork, define two properties to access the generic repositories for the user and order tables. So add a property which will be of type iGeneric repo of type user, which will be our user repo, and the second repository for the order repo, and finally a method to commit the changes. So this method will execute multiple operations in a single transaction to the database. So go to the implementation and then implement the interface. So go to the UnitOfWork. We will remove this set access modifier from the repos to prevent modifying the generic repositories. So let's remove this part, and then we will apply a lazy loading pattern to set the user repository and the order repository. So add two private fields based on the same generic repository of type user repo, and then the order repo. So basically, if the user repo is null, we will create a new instance of the repository by calling new generic repo of type user by passing the context. So add a constructor to inject the context and then pass as an argument to the constructor. As you can see, this coalesce operator is to check if the user repo doesn't exist. It will create a new generic repo of type user. Similarly for the second repository, so this is of type order. And finally, let's implement the save method to commit all the changes by calling context.save changes. Now go and register the UnitOfWork in the persistence installers. So add services that add scope by defining the service type and the implementation type. Now it's time to add simple business logic in the API to test the UnitOfWork. So go to the controllers, user controller, rename it as order, add an HTTP post action to create a new order by returning the ID and receive from body the order entity. This is just for demo purposes. Please don't do this in production. Use DTOs. So we will check if the user exists based on the user ID defined in the order class. So inject the UnitOfWork via constructor. Let's verify if the user exists. So call UnitOfWork, invoke the user repository and get a user based on the user ID. So basically we will check if user is null, we will create the user. Then let's add the order by calling this create method from the order repository. And finally, we will commit all the changes in the database. So we will call the save method. And finally, return order.id. How to validate that the user is created when the user is null and the order is created. Add a new HTTP get method to return an order based on the ID. So call UnitOfWork.orderRepo.get method by passing the ID. So now it's time to test the UnitOfWork in action. So let me add a breakpoint in the create method. Let's run the application. Let's create a new order, define any product name. Let's keep the same parameters with no user ID. Execute it. In this case, user is null. We'll call the create method from the user repository and then create the order. So we will perform in two operations in a single transaction by committing all the changes in the save method. It's executed and we have the newly order which has this ID. So let's return an order by passing the ID. It's executed and as you can see we have the information about the order and the user ID, which is 1, which is the associated user ID from the order. So in this demo we learn how to implement the UnitOfWork pattern with Entity Framework Core in a .NET Web API.